The first one has to do with enclosing a space for a garden that backs up against the side of a previously existing fence. Okay, so if you have your, let's say, the backyard fence modeled here, and you want to enclose a space for a garden that's in the shape of a rectangle, so these would be the dimensions here in red. And so you don't really know, but you have the width here and you have the length of the fence here. And so the one piece of information you know is that the total amount of fencing is going to be 80 feet. So if you notice here, there's 2 equal sides of L. So the equation I can use for this would be 2L's plus 1W has to equal 80. Okay. So if you want to find a formula for this area, so let's say the area here, the area of a rectangle is base times height. Go ahead and rewrite W in terms of L. So if I solve for W here, I get 80 minus 2L. And so I can substitute this in here. And that will probably give me an easier area calculation. It is the 80 minus 2L, exactly like what the width was, times the L, which you can turn into the function. Area is a function of the length, negative 2L squared plus 80L. Thank you. All right, so that would be the formula that you can use to calculate area based on the length L. And so if you're looking to maximize the enclosed areas, the maximum areas are going to be the vertex of a parabola. Okay, so when you look at the sketch of this graph, it's going to be a parabola. Whatever the points are here, the H and K value, up here are going to give you the maximum yield for this particular calculation area in this case. Okay, so in order for us to find that, we need to know what the vertex is. Okay, so the vertex can be found by using negative b over 2a. So our b value was 80, so negative 80 over 2 times our a value is negative 2. The negatives cancel. 2 times 2 is 4, goes into 80 20 times. And so this right here is our x-coordinate. Okay, and so when you're looking for the dimensions, that is exactly what we are trying to find. We're finding the length. Okay. The output for this is going to be what that maximum area is, which I'll talk about here in a moment. But the dimensions that will maximize the enclosed area is going to be a length of 20. And that would mean that our width would be 80 minus 2 times 20, or 80 minus 40. So the width would be 40. So the dimensions would be 20 by 40 for our answer. If the question had asked what is the maximum area, then what you would do is you take this formula right here, and you'd plug in the value the value 20 for x. So I would take, I'm going to call it x's, so negative 2x squared plus 80x, and I'm going to use the width key, x equals 20. When I plug that in, it gives me my maximum area, which is going to be 800 square feet, if it asks for that. Now, this one, it just asks for the dimensions. And you can see right here, that is what the dimensions are, right? So not only just plugging in here to get the y-coordinate, this is your area. 20 times 40 does equal 800 square feet, so you could calculate it in that manner as well.